Hey guys, so today we're going to go through substitution nucleophilic reactions, or also known as SN1 and SN2 reactions. I'll be covering SN1 in a different video, but for this one I'll just be focusing on SN2. This is something that comes up in GAMSAT quite a lot. You're like in these practice questions, for example, you're asked to compare and contrast SN1 and SN2 and determine the mechanism of a particular reaction. And usually you have to choose between like E1, E2, so elimination 1 and 2, and SN1 and SN2. I find it's very helpful though with these sort of questions if you understand what these reactions are beforehand, and I think it just saves a lot of time in the GAMSAT. So for an SN2 reaction, essentially it's just reaction where you get the addition of a nucleophile to a carbon at the same time as you get a leaving group leaving a particular electrophile. So for this mechanism, initially you get the leaving group leaves this carbon, rendering it electropositive, and then you get this nucleophile attacking that electropositive carbon. And this all happens in a one-step reaction. So as you can see here, with the leaving group gone, the attachment of the nucleophile, you get this end result here, which is the nucleophile attached to that central carbon there. Now, some important things to point out is that this is a one-step reaction. The reason why it's called an SN2 is because it's a second order, it has a second order rate law. And essentially that means is that the rate of this reaction is determined by the concentration of, it's determined by the concentration of this electrophile here, as well as the concentration of the nucleophile. So if we increase the concentration of either of those two compounds, you'll get an increase in the rate of this reaction. I think it's also important to point out that this leaving group is usually a halide, so something that's very comfortable with being or having a negative charge associated with it because it is such an electronegative atom. So I think one of the biggest things to compare when you're looking at an SN2 reaction is whether it's a tertiary or primary, secondary, or tertiary compound. I will explain SN2 or SN1 reactions in a different video, but for now I just want you to look at these two graphs and notice the differences between the two. So essentially with an SN2 reaction, you get a higher rate if that compound or if the electrophile is a primary compound. That being it's only got one R group and two hydrogens. Conversely, with the SN1 reaction, you get quite a low rate when there's two hydrogens attached to that central carbon. And as we increase, with the SN2, as we increase the number of corresponding R groups attached to that central carbon, we see a decrease in the reaction rate. So in the GAMSAT, when you're given a mechanism or a reaction mechanism, and it's asking you to determine whether it is a SN1 or SN2 reaction, if the electrophile has multiple hydrogens, in the large majority of cases, it will be an SN2 reactions. We see that SN1 rarely occurs when that central carbon is a primary carbon. So just to make it a little bit clearer about why SN2 reactions prefer primary carbons, refer back to this previous reaction here. As I mentioned before, the leaving group, leaving this central carbon, and the nucleophilic attack occur in the one step. So typically, nucleophiles, when they attack the central carbon, they want it to be as least cluttered as possible. What I mean by that, if we got, with these R groups, if we got multiple carbons, multiple hydrogen atoms hanging off this central carbon here, it'll be very cluttered for that nucleophile to attack that central carbon. However, with more hydrogens, there's less surrounding atoms around this carbon here. And because of that, this nucleophile can easily attack that carbon without getting in the way of any attached carbon groups. Just to finish off, I just want to say a massive thank you to everyone that subscribed so far and also liked my previous video. It's making me super excited about this whole YouTube journey and just makes me really motivated to create more content and share some of the things that I learned away when I was preparing for GAMSAT. As always, if you guys have any questions about what I've discussed today, or you just want some clarification around some of these topics, please feel free to comment down below and I'll do my best to answer them.